Welcome to Glad Labs Podcast. Today's episode, the 70B threshold, how the RTX 5090 rewrites the home lab equation. For years, the world of running large language models, or LLMs, locally has involved a trade-off. The industry standard for truly high-quality reasoning and complex tasks has settled around models with 70 billion parameters. Models like Llama 3.170B, Mistral Large, and Qwen 72B represent a significant step forward in what these AI systems can do, compared to smaller 7 or 8 billion parameter models. However, running these larger models has historically been a challenge for individuals and smaller developers. A 70 billion parameter model in 16-bit precision requires over 140 gigabytes of video memory, or VRAM. Even with techniques to reduce that memory usage, like 4-bit quantization, bringing it down to around 40 gigabytes, the gap between what's available on typical consumer hardware and what's needed has been substantial. Until recently, the most practical path to accessing this level of AI quality was often through cloud APIs, renting computing power from companies like OpenAI or Anthropic, or paying per use. But recent advancements in hardware, and specifically the release of graphics cards like the RTX 5090, are fundamentally changing this equation. This isn't just about faster processing. It's about making this technology accessible. The barrier to entry for having your own private AI intelligence has dramatically lowered. Before diving into the specifics of hardware, it's important to understand why the 70 billion parameter threshold is so important. In the world of LLMs, the number of parameters generally correlates with the model's ability to reason, its accuracy in coding, and its retention of factual information. A 7 billion parameter model can often handle tasks like summarizing text, simple chat, and basic code completion. But a 70 billion parameter model is necessary for tackling complex codebases, multi-step reasoning problems, and understanding specialized data in a nuanced way. The biggest hurdle to running these models locally has been memory bandwidth. Inference, that is, using the model to generate responses, isn't just about the raw processing power of the graphics card. It's about how quickly data can move from the GPU's memory to the processing units. Older graphics cards, even high-end ones, relied on memory interfaces that could become saturated when handling the massive context windows and data caches required by 70 billion parameter models. According to research on running LLMs locally, the hardware evaluation process should prioritize memory bandwidth over raw processing speed for these types of workloads. The RTX 5090 addresses this by introducing a new memory architecture specifically designed to sustain high throughput for demanding tasks, effectively removing that bandwidth bottleneck that previously forced developers to compromise on quality or accept high latency. This shifts the question from "can we run this model?" to "how fast can we run this model?" With this new architecture, a 70 billion parameter model is no longer just a theoretical possibility that crashes the system after a couple of prompts. It becomes a viable foundation for building a personal application. The technical innovation that enables this shift is found in the software used to manage the GPU's memory. One prominent example is vLLM, an open-source project that has become the industry standard for high-throughput LLM serving. vLLM introduces a technique called PagedAttention. Traditional inference engines allocate memory rigidly. As the model generates text, it needs to store a key-value cache for every piece of information it has processed. For a 70 billion parameter model with a long context window, this cache can easily exceed the available VRAM, causing the system to crash or forcing the model to truncate the information. PagedAttention allows the engine to treat the GPU's memory like a hard drive, swapping data in and out as needed. This allows a single GPU to handle multiple requests simultaneously without running out of memory. The RTX 5090's role in this is crucial. While PagedAttention is efficient, it's limited by the speed at which the GPU can fetch data. With the increased memory bandwidth and capacity of the RTX 5090 class hardware, PagedAttention transitions from a memory-saving trick to a performance booster. It allows for significantly larger context windows without the performance penalty of offloading data to system RAM, which is much slower. This means a developer can run a 70 billion parameter model with a 32,000 or even 128,000 token context window locally, effectively matching the capabilities of high-end cloud instances without incurring additional data transfer fees. The decision to run models locally isn't just a technical one, it's a strategic one. The growth of AI startups and the increasing volume of data being generated have created a new class of valuable intellectual property. When a developer relies on cloud APIs for their core AI functionality, they are essentially outsourcing the brain of their application to a third party. Recent trends in the market highlight this risk. The significant funding rounds for specialized AI tools, for example, demonstrate the value of proprietary data. If your application depends on a cloud API, you're subject to the provider's terms of service, rate limits, and potential future price increases. Running a 70 billion parameter model locally provides a path to what's been termed sovereign infrastructure. By deploying the model on a home lab or a dedicated local server, the data and the intelligence remain under the developer's control. The RTX 5090 makes this economically feasible. The cost of electricity for a high-end GPU is minimal compared to the cost of API tokens for a high-volume application. Furthermore, this shifts the maintenance burden. Cloud APIs offer uptime guarantees and automatic scaling. A local model requires manual management, but it eliminates the risk of dependency on an external provider. For applications dealing with sensitive data, medical records, proprietary code, or financial analysis, the ability to run a model locally isn't a luxury. It's a compliance requirement. Implementing a 70 billion parameter model locally requires a new approach to application architecture. You're no longer simply making an HTTP request to an external service. You're managing a persistent GPU resource. A typical setup involves a few key components: the GPU itself, an inference engine like vLLM or Llama, and a standard web framework for serving the API. A practical implementation might look like this. The inference engine, like vLLM, runs the model on the GPU and exposes an API compatible with the OpenAI standard. This is important because it allows developers to use the same client libraries they're already familiar with for cloud APIs, minimizing the amount of code they need to rewrite. The application layer, often built with FastAPI, acts as the glue, handling authentication, user requests, and passing them to the local vLLM instance. And for enhanced performance, a data layer using Postgres with a vector extension can be used to store and query data locally, providing context for the 70 billion parameter model through a technique called retrieval augmented generation, or RAG. A Docker Compose file could be used to orchestrate this setup, ensuring the GPU is properly allocated to the inference container. In this configuration, the RTX 5090 is fully utilized by the vLLM container, with the GPU memory utilization flag maximizing batch sizes and throughput. The FastAPI container then sits in front, ready to serve requests to the end user. The arrival of the RTX 5090 represents a turning point in the democratization of AI. It brings the power of 70 billion parameter models from the cloud to consumer hardware. This doesn't mean cloud APIs will disappear. They will remain essential for massive, distributed tasks. However, for the vast majority of applications, from personal coding assistants to internal business tools, a local model is now a viable, high-performance alternative. The research surrounding the next generation of models suggests they will only get smarter and larger, creating a positive feedback loop. Better models demand better hardware, and better hardware enables better models. By adopting the RTX 5090 and the vLLM ecosystem now, developers are positioning themselves at the forefront of this evolution. The calculus has shifted. The cost of maintaining privacy is no longer outweighed by the price of a cloud subscription. The latency of local inference is now comparable to the network latency of the internet. And the quality of a 70 billion parameter model is unmatched by anything else. The home lab is no longer just a hobbyist playground. It's becoming the standard for intelligent application development. To evaluate if this is right for you, consider whether your application requires complex reasoning or coding capabilities beyond simple summarization. If so, a 70 billion parameter model is the right choice. Don't settle for a smaller model if you need high fidelity. When building your local infrastructure, prioritize the GPU's memory bandwidth and capacity over raw clock speeds. The RTX 5090 class hardware is specifically designed for this workload. And for production-grade local serving, use vLLM. Its PagedAttention architecture is essential for managing the memory overhead of 70 billion parameter models. Containerize your stack using Docker and Docker Compose to ensure reproducibility and simplify dependency management. Finally, integrate retrieval-augmented generation to get the most out of your 70 billion parameter model, using a local vector database like Postgres with Vector to create a private, searchable knowledge base. Thanks for listening to Glad Labs podcast. Visit gladlabs.io for more episodes, articles, and insights. See you next time.